Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. Now make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so our problem here is 5 to the power of x is equal to 6. So right now, just simply taking a glance at this problem, I know that x here, this is going to be a decimal, because I know that 5 to the power of 1, this is equal to 5, and 5 to the power of 2, this is equal to 25. And 6 is somewhere in between 5 and 25, meaning x is somewhere in between 1 and 2. However, x is a decimal, and it's really hard to just guess for a decimal. So, to find the value of x here, this is my solution. So I first start with 5 to the power of x is equal to 6. Now I'm going to go ahead and take the log on both sides. So now I have log 5 to the power of x is equal to log 6. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times log a. So log 5 to the power of x, I'm going to do the exact same thing. And the reason why this property is so useful is because right now we have 5 to the power of x equals 6, and because we know that x is going to be a decimal, it's going to be really hard to find out the value of x just as an exponent. So now, as you can see, once we change the exponent x, once we make it go to the front, it's going to be a real term, and then it's going to be much simpler to solve for it. So I have log 5 to the power of x is equal to log 6. And now if I move x to the front, I get x times log 5 is equal to log 6. Now I'm simply just going to divide both sides by log 5. So then these two cancel out, and now I'm left with x is equal to log 6 over log 5. Now log 6, this is equal to 0.77815, and log 5, this is equal to 0.69897. So now if I divide these two, I get 1.1132827. So this is my answer. Alright, so I have 4 to the power of x is equal to 2 to the power of 3x. So I want to find the value of x here. Now first off, 4, this is the same thing as 2 to the power of 2. So if I replace 4 with 2 to the power of 2, I get 2 to the power of 2 to the power of x is equal to 2 to the power of 3x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, that's going to equal 2 to the power of 2 times x, which is the same thing as 2x. Now this is equal to 2 to the power of 3x. Now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, 2x is equal to 3x. Now, to solve this, I'm first going to subtract both sides by 3x. So then these two cancel out, and now I'm left with 2x minus 3x is equal to 0. Now, if I factor out x from here, I get x times 2 minus 3 is equal to 0. 2 minus 3 is negative 1, so now I have negative x is equal to 0, and if I divide both sides by negative 1, I get x is equal to 0 divided by negative 1 is 0. So my answer is x equals 0. Now to check, my original equation was 4 to the power of x is equal to 2 to the power of 3x. Now I know that x is equal to 0, so now I have 4 to the power of 0 is equal to 2 to the power of 3 times 0. Now 3 times 0 is simply 0 because anything times 0 is 0. So now I have 4 to the power of 0 is equal to 2 to the power of 0. Now any number to the power of 0 is simply equal to 1 besides 0 itself. So 4 to the power of 0 is going to equal 1, and 2 to the power of 0 this is also equal to 1. So I have 1 is equal to 1, and because this is right, my solution is right as well. Alright, so I have 3 to the power of x minus 2 is equal to 2 to the power of x plus 1. So right here, I want to find the value of x. So for my solution, first start with 3 to the power of x minus 2 is equal to 2 to the power of x plus 1. Now, I'm going to take the log on both sides. So now I have log 3 to the power of x minus 2 is equal to log 2 to the power of x plus 1. Now, if I have something in the form log a to the power of b, I can simply move this exponent b to the front of the logarithm. So this is going to equal b times log a. So in this case, I can move both x minus 2 to the front as well as x plus 1 to the front. So now I have x minus 2 times log 3 is equal to x plus 1 times log 2. Now for both of these, if I distribute log 3 and log 2, well, first off, let's start with x minus 2 times log 3. X times log 3 is simply x log 3, and negative 2 times log 3 is negative 2 log 3. This is equal to x times log 2 is x log 2, and 1 times log 2 is simply just log 2. So now I have x log 3 minus 2 log 3 is equal to x log 2 plus log 2. Now I'm going to subtract x log 2 on both sides. So then these two cancel out, and now I'm left with x log 3 minus x log 2 minus 2 log 3 is equal to log 2. Now I'm going to add 2 log 3 on both sides. And these two cancel out, and now I'm left with x log 3 minus x log 2 is equal to log 2 plus 2 log 3. Now if I factor out x from here, I have x times log 3 minus log 2 is equal to log 2 plus 2 log 3. And 2 log 3, remember how I can just bring this to the front. So now I have x times log 3 minus log 2 is equal to log 2 plus log 3 squared. Now if I divide both sides by log 3 minus log 2, these two cancel out, and left with log 2 plus log 9, 3 squared is 9, over log 3 minus log 2. Now log 2, this is equal to 0.301, plus log 9, this is equal to 0.954. Now I have this over log 3, this is equal to 0.477, minus log 2, again, this is equal to 0.301. So now this is equal to 1.255 over 0.176, which is equal to 7.13. So this is my answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this problem without a calculator. So we have 2 to the power of 20 minus 9. Now 2 to the power of 20, this can actually be rewritten as 2 to the power of 10 squared. Because remember, these two multiply each other. So we could actually reverse this and rewrite this as 2 to the power of 10 to the power of 2. And I'm subtracting this with, well, I'm going to replace 9 with 3 squared. Now x squared minus y squared is equal to x plus y times x minus y. So 2 to the power of 10 squared minus 3 squared would equal 2 to the power of 10 plus 3 times 2 to the power of 10 minus 3. Now, 2 to the power of 10 is 1024. So we have 1024 plus 3 times 1024 minus 3. Now, 1024 plus 3, well, that's 1027. So we have 1027 times 1024 minus 3 is 1021. Now, I'm actually going to rewrite 1027 as 1000 plus 27. And I'm going to rewrite 1021 as 1000 plus 21. Now, 1000 times 1000 is what? Well, we have 1 with 1, 2, 3, 4, 5, 6, 0. So this would be 1 million. So we have 1 million plus, now 1000 times 21 is 21,000. Plus, now 27 times 1000 is 27,000. And finally, 27 times 21 is, we could rewrite, if we want to simplify this, 27 times 21 27 times 21 is 567. So now if we add all of this up, we get 104 8, 5, 6, 7. So this is our answer.